Hi, my name is Matt Castriata, and I'm a security engineer here at Rubrik. Rubrik has designed an innovative approach to cyber resilience. We've combined our platform security architecture with cyber attack detection and remediation workflows. You build thick walls, and the bad guys continue to find ways to get around them. But our focus is different. It's security at the point of data. Ideally, you've already backed up your critical infrastructure with Rubrik, and by its nature, the platform provides assurance that your data has not changed since it was written. This immutability, combined with our zero trust cluster architecture, will help you sleep at night knowing that you can restore your data in the case of a cyber attack. However, restoring your data is really only half the battle. What was the blast radius of that attack? How can I restore just what I need to be up and running quickly? What was the sensitivity of the data that was exposed in the event that my data was exfiltrated? I'll show you through a mock forensic event using Rubrik technologies how you can quickly identify the data sets that have been affected, initiate a recovery of your most critical data, and determine the sensitivity of the affected data to inform your communications after the fact. It all starts with an event, and in this case, the event was an anomalous file system activity alert on two VMs that I'm backing up with Rubrik. Through our machine learning model, we detected that the change rate, backup over backup, fell out of bounds of what is the typical change rate for those VMs. Because of that, we basically fire off an anomalous file system activity alert and then surface exactly what's changed, what's been deleted, what's been modified, and what's been created. The second piece to this is to identify, are there any suspicious files on these VMs? Because the change rate fell out of bounds, we then go in and we check the metadata for each of the files to make sure that it's still intact. If the metadata is not intact for those files, we check the randomness of that file. If the randomness is really high for that particular file and the metadata has been overwritten, and by the way, there may be some suspicious file extensions like .encrypted and things like that, we're going to mark those files as suspicious. You can go in and investigate exactly what we're seeing for this particular VM. So I'm looking at a VM SH1 Radar 01. I click on Investigate Snapshot. It takes me right into a file browse view, and I can see exactly what's changed and what we mark as suspicious. So I navigate through the file system, through the C drive. You can see that most of the changes in the file shares folder go a level deeper. I can see that, it seems to be widespread across all my departmental shares, but I'll look at legal first because this is my biggest concern. So I click on the legal department folder. Now I'm going to filter by deleted and suspicious because I think it really shows a view of what a typical ransomware signature looks like, right? You've got a legitimate file here, in this case, a Word document that had been deleted, and an illegitimate file with basically the same name except a .encrypted extension marked as suspicious that's been added to the file system. Basically, the sizes are almost equivalent. So we can determine with some certainty that a ransomware event has happened here, right? Lots of legitimate files deleted, lots of illegitimate files added and marked as suspicious. Maybe I only need these first 4 files to get back to business. Maybe I don't need to recover the entire snapshot. But if the blast radius is so widespread for that particular VM, your calculus may be to then go in and recover the entire snapshot. And we give you all of the features that you see within our data protection solution. We give you those here in Polaris. We basically orchestrate it here from this Polaris platform. And you can live mount, you can export, you can instantly recover, et cetera, et cetera. But maybe I only want to restore these first 4 files because these are the most critical. So I go in and I select these files, I click next, and we give you basically 3 options. You can either download those files locally, overwrite the original file back to its source, or recover to a separate folder on the source. That's really it. It's providing that blast radius, that view of the blast radius, and the surgical recovery capability to get up and running quickly. Subsequent forensics had determined that some exfiltration had happened, unfortunately. Whether it's looking at your firewall logs or your network logs, you've now determined that some exfiltration had happened. So you then have to go in and determine what is the sensitivity of the data that's sitting in these shares. So I go and I click on our data classification capability, and I can see exactly how many sensitive hits, how many objects that I'm scanning, how many files have sensitivity associated with it. But I'm really interested in that one VM that I was just looking at to determine what is the sensitivity of the data that is in that VM, because I know for certain now that that VM was exposed to a cyber attack. So I go into my object view and I click on SH1 Radar 1. This is being classified by our data classification capability. I get the same exact view, a file browse view. I can go through the C drive. I can sort by hits. I can go to the file shares folder. I can go to the legal department folder. And now I see that the legal department folder has 46 sensitive hits associated with it. And it looks to be only on one file. So when I go and I look at what are those 46 hits, I get a great breakout here on the right of exactly what those hits are. And I can see that those 46 hits violated the US PII policy. And when I scroll down, I can see that this is the file that has those 46 hits. So I want to find out what data sets did it violate as a part of that policy. When I click on US PII, I shift to an analyzer-centric view. So now I can see exactly what data sets live in that file. In this case, they're employer identification numbers. And if this were the only location that were exposed as a part of that cyber attack, your calculus may be to say, employer identification numbers are kind of low on the scale of sensitivity. If they were social security numbers or credit card numbers, absolutely, that would be something that you would want to basically inform your customers or your business partners about. But in this case, it's a fairly low criticality, and you may determine that if the cyber attackers happen to have this data, that they can, essentially have fun with it. I'm not going to pay the ransom. I'm going to recover, get back to business, and move on from this particular attack. So this is one way that you can identify exactly what's been exposed, but there's additional capabilities here as well. I can see details about the locations that have been exposed. How big is the location? When was it last accessed and modified? How many total files exist in that location? But I can also look at the user and ownership and permissions of that particular location as well. Who owns it? And what are the file system permissions of that particular location? Hopefully this helps you get an understanding of how Rubrik can help in the case of a cyber attack. Again, my name is Matt Castriata. Thanks for listening.